Good afternoon. Today we are going to do the paper grade 11 from the Mpumalanga Province Department of Education, the control test which was written in March 2025. The paper was worth 50 marks and it was written in 1 hour. So when you come across, don't forget to subscribe, share, like, comment, as it will motivate us to be preparing more videos. Now let's go to the instructions. Here are the instructions. You are given the number of questions, which is from question 1 to question 3. The question paper consists of 3 questions, which is question 1 to question 3. You are required to answer all the questions. Then you are told that number the answers correctly according to the numbering system used in the question paper. So numbering is very important. You are also required to show all the calculations here. Show all calculations, diagrams, graphs, etc. that you used in determining your answer. Answers only will not be given full marks. Then diagrams are not necessarily drawn to scale. You are required to write neatly and legibly. Then let's go to the questions. Here is question 1. So the first question 1.1.1, there it is. You are given x squared minus 2x equal to 8. So first step, you have to standardize the equation. So it's going to be x squared minus 2x minus 8. When you transpose this 8 to the other side, this is equal to 0. I recommend the use of the quadratic formula if the formula is not specified. So write in the quadratic formula, x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So what is our a? Our a is equal to 1, which is the coefficient of x squared. Our b is equal to minus 2, which is the coefficient of x, and our c is equal to minus 8, which is the constant substitute. So our x is equal to minus our b. It's minus 2 plus or minus the square root of b squared. It's going to be minus 2 squared minus 4 ac. But our a and our c, take note there, our a and our c, our a is 1, our c is negative 8 all over 2a. Our a is 1. Then from there, trust your calculator, x equal to, or x equal to. So what are we going to get? Take the calculator. So this is going to be equal to minus b. So it's minus our b. It's a negative 2 plus the square root of b squared, which is a negative 2 squared minus 4a is 1. C is a negative 8. All over 2. Our a is 1. So we get our answer as 4. Then we check the other one. We put plus there. Now let's put minus. The other one is minus 2. So our answers are 4 and minus 2. So our answers are 4 and minus 2. You can also use factorization, but as I said, I recommend use of the quadratic formula. Then we move to the next question. There it is. That is question 1.1.2. It's saying x squared, 4x squared minus x minus 2 equal to 0. So we use the quadratic formula, and our a in this case is equal to 4. Our b is equal to -1. Then our c is equal to -2. Substituting the quadratic formula, we are going to have our x being equal to minus b is -1 plus or minus the square root of b squared is -1 squared minus 4. Our a is 4. Our c is -2 all over 2. Our a is 4. Then we have to punch that on our calculator. Our x equal to, or our x equal to, we go to our calculator. So let's check on our calculator. So it's gonna be minus our b is -1 plus the square root of b squared, which is -1 squared minus 4. Our a is 4. Then our c is -2 all over 2a to the a is 4. Thus giving us the said, but this question strictly says to 2 decimal places. The question strictly says to 2 decimal places. So we change. That is what we are getting there. So to go to 2 decimal places, we concentrate, we count 2 numbers after the comma, then we concentrate on the third one, which is less than 5. So our final answer to 2 decimal places will be 0.84 there. Then we move, put negative there. Then we want our answer to 2 decimal places. There it is, we concentrate on the third place. 1, 2, 3. So since it's less than 5, it becomes -0.59. Then we proceed to write the correct answer. So we are having 0.82 as our first answer. So it is 0.84. Then the other one is going to be 0.59, which is negative. Then we move, we are on 1.1.3. So 1.1.3, that's inequality. First step, we standardize, we remove brackets, so it becomes x squared minus x. Then when we transpose the 6 to the other side, it becomes minus 6 is greater than or equal to 0. Then when dealing with inequalities, we first need to get the critical values. We need to get the critical values. To get the critical values, we now replace the inequality sign with equal sign. X squared minus x minus 6 equal to 0. Then from there, we are going to apply the quadratic formula. Here is our quadratic formula. Again, we are going to apply it, but in this case, our A equal to 1, our B equal to -1, our C equal to -6. Solve. So our X is gonna be equal to minus B, which is -1, plus or minus the square root of B squared, which is -1, squared minus 4, A is 1, C is -6, all over 2A. Our A is -6. Sorry, our A there is 1. Then punch your calculator. So punching the calculator, we are going to get our answer minus -1 plus the square root of B squared, which is -1, squared minus 4A, which is 1, then C, which is -6, all over 2A, our A being 1, we get an answer of 3. Then we also have to put minus there to get an answer of -2. So it means our X is equal to 3 or a -2. But take note, we are not solving an equation, so our equation doesn't end here. We need now to solve the inequality. So we are going to use the graphical method. So if we are to use the graphical method, we now need to sketch the graph of this quadratic expression, quadratic function x squared minus x minus 6. Since our A is positive, our graph is going to be U-shaped. It's going to be cup-shaped. So sketching the graph is going to be something like this with our intercepts. Here is -2 and here is +3. Then we read the inequality. It's saying this function must be greater than or equal to 0. Greater than 0, it means it must be above the horizontal axis. So here is our horizontal axis. The part which is above the horizontal axis is this one. Then how do you write that part as an inequality? As we can see, it means we are talking of from -2 going to the left, or from 3 going towards the right. The inequality therefore is going to be written as x is less than or equal to -2, or our x is greater than or equal to 3. This becomes our final solution. Then we move to the next question, 1.1.4. Going to 1.1.4, it's equation with surd. So the first step is to make sure that surd is on one side and the other terms are on the other side. So we are going to be left with x plus 1 being equal to 1. When we transpose the 2x there, it's going to be minus 2x. We have to remove the surd. So in this case, we are going to square both sides. So this and the square root will be left with x plus 1. Then the other side, it means we are going to expand. It becomes 1 minus 2x multiplied by 1 minus 2x. This reduces to x plus 1 equal to, so the 1 and the 1 multiply, we get 1. The 1 and the that one will meet. It means we are going to have a negative 2x. Then we now use the second term to multiply everything in the second bracket, this one and this one. We are going to get again a negative 2x. Then this one and the second one, negative and negative is positive 4x squared. So this reduces to x plus 1 being equated to 1 minus 4x minus 2x minus 2x. They are like terms, they reduce to minus 4x plus 4x squared. Now let's move everything to this side and standardize. We are going to start here, so it becomes 0 equal to, we start by writing is 4x squared. Then we have minus 4x. Then this one comes to this side, it becomes minus x. Then taking again this one to that side, we are having a positive 1, which is there. Then when we take that, it's minus 1. So this one will cancel out. So we are left with 0 being equal to 4x squared minus 5x. Here, x is a common factor, x. Then we are having 4x minus 5 being equated to 0. When we have 2 or more factors being equated to 0, just equate each factor to 0. So our x is equal to 0, or our x, 4x minus 5 is equal to 0. So 4x transpose that one to this side will be equal to 5. Then x is equal to 5 over 4. But always remember, when solving equations with sets, it is very important that we test our solutions. So let's substitute 0. We want to test our solutions. Let's substitute 0 there. 2, 0 plus square root of 0 plus 1 equal to 1. As we can see, this side we are getting 1, which is equal to 1. So it means 0 is a solution. Let's try again. When we put 5 over 4, it means here we are going to have 2, then 5 over 4 plus square root of 5 over 4 plus 1 equal to 1. If we check punching this on our calculator, it's giving us an answer which is greater than 1, which is not equal to 1 there. Therefore, this one is not an answer. Conclusively, our x is equal to 0. Okay, you just have to punch your calculator to confirm here. Then we move to the next question, which is a simultaneous equation. If we check, this is the simultaneous equation, question 1.2. So this is our equation 1. Then this is our equation 2. We are going to use substitution method. So we formulate equation 3 using equation 1 by making y the subject of formula. So y is equal to 7 transpose the 4x to the other side. So it becomes 7 minus 4x. This becomes our equation 3. Let's substitute equation 3 in our equation 2. It simply means wherever there is x, wherever there is y, we are going to put 7 minus 4x. So it becomes 3x squared plus 2x. Where there is y, we put 7 minus 4x. That must be equal to y, which is 7 minus 4x squared. Let's expand. We are going to have 3x squared plus 2x. By that, it's going to be plus 14x. Then 2x times that, it's going to be minus 8x squared equal to, here expanding at 7 minus 4x. 7 minus 4x. If you are to check expanding this one, and this one, it gives us, okay, let's do it here. So we are left with 3x squared here minus 8x squared there. It's going to give us minus 5x squared plus 14x being equated to 7. 7 is gonna be 49. Then 7 and 4x, it's gonna be minus 28x. Here, minus 28x. Then the 4 there and there, gonna be plus 16x squared. So standardizing, here will be 0 equal to, we have 16x squared. Taking this 5x to that side, it becomes plus 5x squared. We have got minus 28x minus 20x. It becomes minus 56x. Taking the other one to that side, it becomes minus 42. Sorry, minus 14. It was positive minus 14x. Then we are having plus 49. So our equation becomes 21x squared minus 70x plus 49. If we are to divide that entire equation by 7. If you are to divide the entire equation by 7, here we are saying dividing throughout by 7. Since 7 is a LCM, we are going to have, okay, let's leave dividing by 7, because sometimes it's difficult to see that 7 is a common factor. So from there, we are going to apply the quadratic formula. So the quadratic formula with what? A equal to 21, B equal to negative 70, then C equal to 49. We are going to have our X sorry. So from there, using the quadratic formula, our X will be equal to minus our B is minus 70 plus or minus the square root of B squared, which is minus 70 squared minus 4. Our A is 21. Our C is 49 all over 2A. Our A is 21. Simplifying, we go to our calculator. So we are going to have minus, then minus 70 minus B plus the square root of B squared is a negative 70 squared minus 4A is 21. C is 49 all over 2A. 2, our A is 21. We are getting 7 over 3 is our answer. We are getting 7 over 3. The other one, take note, we are getting 7 over 3. Then the other one, we just have to go put a negative. The other one, it's 1. So X is equal to 7 over 3 or 1. So let's go X equal to 7 over 3 or X is equal to 1. We now want the Y value because we are solving for simultaneous equation. Remember, we said our Y, from our third equation, our Y is equal to 7 minus 4x. So it means here our Y is equal to 7 minus 4x. When our Y is 7, or when our X is 7 over 3, it means our Y is equal to 7 minus 4. Our X is 7 over 3. Or our Y is equal to, when X is equal to 1, it's going to be 7 minus 4, 1. This one is going to give you 3. Then the other one, using your calculator, y will be equal to 7. Use your calculator. It's 7 minus 4. 7 over 3. It's minus 7 over 3. So these are the corresponding values of our y. Then we move on to the next equation. The roots of the quadratic equation are x is equal to that one. Calculate the value of k for which the roots are equal. We have to know that for the roots to be equal, we are now on nature of roots. For the roots to be equal, our discriminant must be equal to 0, and the discriminant is that part under the root sign. So discriminant is equal to 0 for equal roots. So what's our discriminant in this case is this part under the root sign is 13 minus 2k must be equal to 0. Then 13 is equal to 2k when we transpose the k to that side. Conclusively, we can now therefore divide both sides by 2. So our k is equal to 13 over 2 for the roots to be equal. All right, we are now on question 1.4. We are given that equation, then you are required to calculate the values of p for which the root of the equation are non-real. So one method that we can use, we just expand that. So it's going to be x is 1.4. It's going to be x plus 5 squared being equal to 1 minus p squared. So it's x plus 5 being equal to 1 minus p squared. Expanding this, x squared plus 5x plus 5x plus 25 being equal to 1 minus p squared. This reduces to x squared plus, these are like terms, 10x plus 25 transpose is going to be minus 1 plus p squared being equal to 0. So our equation becomes x squared plus 10x plus 24 plus p squared equal to 0. Then from there, you are asked for which the equations for which the roots are non-real. So for non-real, our discriminant must be less than 0, and our discriminant, we are referring to the part b squared minus 4ac, and in this case our a is equal to 1, our b is equal to 10, then our c is equal to 24 plus p squared. And then substituting that, we said this must be less for non-real roots. So from there, it's going to be b squared. Our b is 10 minus 4a is 1. Our c is 24 plus p squared. This one is less than 0, so it's gonna be 100 minus 96 minus 4p squared, which is less than 0. 100 minus 6 is 4 minus 4p squared less than 0. Divide throughout by 4. It's gonna be 1 minus p squared less than 0. This is difference of two squares since 1 is given as 1 squared. So it means we are going to have 1 minus p, then 1 plus p less than 0. Then from there, here we have to determine critical values. So the critical values, we replace the inequality sign by an equal sign. So we are saying 1 minus p, 1 plus p is equal to 0. Therefore, since we have two factors equated to 0, we equate each factor to 0, or 1 plus p equal to 0. So our p is equal to 1, or our p is equal to -1. But take note, this is an inequality, not an equation. So we need now to solve the inequality. We come here to the standard. It's saying minus, so it means the graph, the function, is supposed to be mountain shaped. So it means we are going to sketch the graph of this nature with -1 and +1. Then we check the inequality. It is saying less than 0. We want the part which is below. Since it's saying less is below the horizontal line, so it means we'll be talking of this side and this side. So in other words, we are talking on the left of -1 and on the right of +1. So the solution means our P is less than -1, or our P is greater than +1. Then let's move to the next question. Then we move to the next question. So we are on question 2.11. On question 2.11, so let's simplify this. We are going on question 2.11. So here we are, question 2.11. This is what we are given. So the first law that we are going to use is if you are given a to the power m divided by, multiplied by a to the power n, we have to add the powers. It becomes a to the power n, m plus n. So you can come from this side going there. So it means this first term there can be written as 3 to the power 2n, 3 to the power 2n multiplied by 3 to the power 2. Then another law we are going to use, it says a to the power m divided by a to the power n, and we have to know that divided is the same as over, which is the same as a to the power m divided by a to the power n must be equal to a to the power m minus n. The exponents subtract each other, so it means on the next one we are going to come up with 9 minus 9 to the power n divided by 9 to the power 1. Then it's going to be over, or over, we are having 2, then 3 to the power that we are going to apply the first rule that was applied there. So it's gonna be 3 to the power 2n then 3 to the power 1. Perfect. Then we move to the next step. We have 9 there. It can be written as 3 squared. So if we check where there's 9, this 9 can be written as 3 squared, then raised to the power n, where there's 9 to the power n, because our 9 here is 3 squared. Then it's raised to the power n. But there's a law that we are going to apply. If we have a to the power m, then we raise it to the power n, we multiply the exponents as a to the power m n. So applying that law here, it means we are going to be left with 3 to the power 2n multiplied by, simplifying there, it's going to be 9 minus 3 to the power 2n here over 9 or over 2 times 3, it's 6, multiplied by 3 to the power 2n. Then from there, we can factor out 3 to the power 2n on the numerator. Then we'll be left with 9 minus 1 over 9 or over 6, 3 to the power 2n. Then the 3 to the power 2n will divide each other. The question is saying without using a calculator. So take note to simplify the fraction there. We now need to simplify the fraction. To simplify the fraction, what are we going to have? 9 minus 1 over 9. It gives us, this one is the same as over 1. So how are we going to simplify the numerator? We just say 9 times 9, it's 81, minus 1 times 1 there, or over 1 times 9, which is 9 there, divided by 6. So it's 80 over 9. 6, take note, it's 6 over 1. So it means we are going to say multiplied by 1 over 6. Our final answer is 80 divided by 54. Then we can divide throughout by 2. This becomes 40 over 27 is our final answer. Then we go to question 2.1.2 there. So it means we have to simplify the denominator. It means it's going to be 3 minus root 3 multiplied by 3 minus root 3 squared all over. There we can separate, it's root 3. Where there's 6, we can apply law of surds. We have to know that root AB is equal to root A times root B. So since our 6 can be written as 2 times 3, it means that can now be written as root 3 root 2. Take note here, how did this one come? For root 6 there, root 6 can be written as root 3 times 2. So we separated it there. So simplifying, we are going to get this one and this one, 9. This one and this one is minus 3 root 3. Then this one and that one, said this. Then we are here, it's minus 3 root 3. Simplify there. Plus 3 all over root 3 times root 3. It's going to give us root. It's going to be 3. Then it's 3 root 2. Simplify there. It's going to be 9 plus 3 is 12. Then plus minus 3 root 3 minus 3 root 3 is minus 6 root 3 all over 3 root 2. We have to rationalize the denominator. If you are to rationalize the denominator, it means we have to multiply both the numerator and the denominator by root 2. So it's multiply here by root 2. Come multiply here by root 2. So it means 12 times root 2. This will be equal to 12 root 2 minus this multiplied. So it means under root sign applying, we are going to have minus 6, 3 times 3 there. So 3 times 2. So it's going to be 6 root 6 all over this root 2, and root 2 is 2 times that is going to give us 6. When you distribute the 6, 12 divided by 6 is going to give us 2 root 2 minus root 6. This becomes our final answer. Then we go to the next question. Then we go to the next question. Question 2 point. So for x without using a calculator, there it's gonna be 2.2.1. That one, we are going to apply the rules. We have to know that the nth root of a is equal to a to the exponent of 1 over n. So that can be written as 32 to the power 1 over x must be equal to 128. Then check these bases if they cannot be expressed as exponents with the same base. 32 can be written as 2 to the power 5. 32, if we check, 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32. 2 to the power 5 equal to, if we say add another times 2 there, it's gonna be 64 times 2 there, it's 128. This will be equal to 2 to the power 7, this other side, 2 to the power 7. But take note, this 32, 2 to the power 5 is being raised to the power 1 over x. Then on our left-hand side, we are going to apply another rule. It says, we discussed it earlier, a to the power b to the power c is equal to a to the power bc. So it therefore means that we multiply the powers there, it becomes 2 to the power 5 over x must be equal to 2 to the power 7. Since our bases are the same, it means our exponents can be equated. 5 over x is equal to 7. We cross multiply, this is the same as over 1, so we are left with 5 being equal to 7x. dividing both sides by 7. So our x is equal to 5 over 7. Then we go to 2.2.2. So that one, we are having that. But if we are to check the first term, we can apply this law because our exponent there, half, can be written as this half can be written applying this rule. Our half, if we check, can be written as quarter times 2. We are linking this half and this quarter, so our half can be written as quarter times 2. So it means this equation can be written as x to the power quarter squared, which gives us half x to the power half minus 3x to the power quarter minus 10 equal to 0. Then here, let k equal to x to the power quarter. We use the k method. It becomes k squared minus 3k minus 10 equal to 0. We can use quadratic formula, but the problem with our quadratic formula, will be forced to use the calculator. But the question strictly say without using a calculator. So we can use factorization here. How do we factorize this? So factors, we need product, which is the coefficient of x, k squared, and the constant. So 1 times we are getting negative 10. The sum, we take the middle term there, which is minus 3. The factors, we want two numbers. When multiplied, we get negative 10. When we add them, we get negative 3. So two numbers that can give us negative 10. When you multiply them, it can be negative 10 and 1. It can be negative 1 and 10. It can be 5 and negative 2. It can be 2 and negative 5. But we want the ones which will give us negative 3. When we add them, negative 10 and 1, we can't. Negative 1 and 10, we can't. 5 minus is positive 3. So the correct set is this one. So our factors is 2 minus 5. So using that, we can now expand here. It becomes k squared minus plus, where the sum we substitute with factors, plus 2k minus 5k minus 10 equal to 0. Factorize, we now concentrate on the first two terms. The common factor there is k. Then we are left with the k plus 2. Then we'll concentrate on the last terms there. The common factor is minus 5. We are left with k plus 2, which is equal to 0. Then we are having k plus 2 for the repeated factor. Then the other factor is k minus 5 equal to 0. Take note, when we have factors being equated to 0, each factor is equal to 0. K plus 2 equal to 0, or k minus 5 equal to 0. It's k minus 5, not k. Here, k minus 5 equal to 0. So k is equal to minus 2, or k is equal to 5. From there, we can now solve for our answer there. We are told x to the power quarter, so we can now substitute x to the power quarter is equal to a negative 2. Raise it to the power 4, here to the power 4. So conclusively, our x is equal to, here it becomes 16, or our x to the power quarter is equal to 5 raised to the power 4 here, raised to the power 4 here. So our x is equal to 5 times 5, 25 times 5, 125 times 5, 625. Then, whenever here our fractions, our denominators are even, here, it's typical of equations with surds. It's typical of equations with surds. So you can test your answers. If you are to test your answers, let us try to check our answers. If you substitute 16 here, if you substitute 16, 16 to the power half, the square root of 16 is 4. Let's check. Minus 3. Then we have 6. Let's do the checking. Let's do it here. We say 16 to the power half, which is 4, minus 3. 16 to the power quarter, the fourth root we know is 2. The minus 10. If we were to check 4 minus 6, we are getting a negative 2 minus 10. This is not equal to 0. This is not equal to 0. Let's check with 625. There it's gonna be square root of 625. It's gonna be 25 minus 3 multiplied by the fourth root of 625, which is 5, minus 10 is equal to 0. If you check, 25 minus 15 is 10 minus 10 is 0. So the correct answer here, it means 16 is not a solution. Therefore, x is only equal to 625. So we have to take note for when it comes to equations with surds. Sometimes they don't bring surds directly, but they bring them with exponents, which are fraction. If the denominators are all even numbers, it means it's typical of equations with surds. So you have to check whether the solution is correct at the end. Then we go to the next question. Here you are given in the diagram below, P is that point in the Cartesian plane, A is a point on the positive x-axis. That is what we are provided. There is the diagram. Then the first part is saying determine with the aid of the diagram the following, the length of OP. So whenever you are solving these types of questions, first step, drop a perpendicular with respect to the x-axis. So it means this x negative 6, this is 8. So to solve for OP, we are going to apply the Pythagoras theorem, that is question 3.1.1. So it's gonna be x squared plus y squared equal to r squared. This is Pythagoras theorem. Pythagoras theorem. Then x, we realize that it's negative 6 squared plus y, which is 8 squared. Y, which is, we must be equal to OP squared. This simplification is 100 is equal to OP squared. Always know that OP is always positive. The terminal is always positive. So OP is equal to 10 units. Then tan theta. Tan theta, you have to know that tan is given by y over x. Y over x. Tan in Cartesian plane is given by y over x. Here is equal to y over x. Our y is 8, so tan theta 8 over x, which is minus 6. So the answer is equal to minus 4 over 3. Then the last one, sine theta plus cos theta. You have to know that sine is given by y over r. Cos theta is given by x over r. That is in Cartesian plane. And if the angle that we are talking about is at the origin measured in an anti-clockwise direction from the positive x-axis, so there it therefore means that simplifying y, we found it to be 8. So it's gonna be 8 over r, which is 10, plus x is minus 6 over 10. So our answer is 8 over 10 minus 6 over 10, which is giving us 2 over 10, which is equal to 1 over 5. Then we call it. Thank you very much. Enjoy our sessions.